Alright, let's begin. Alright, this is calculus. This is 3.6 homework here. I got 1, 2, 3, 4, 5. 5 problems to go. And let's jam. So, first things first. Let me get this all situated so it's happening well. Okay. So, number 5. Here's what we got. We have to take the derivative of this. So it says find dy dx. So you should notice that this is not an implicit differentiation because the y has already been solved for. This is just kind of get us used to deriving it here. So technically, you should kind of see it a different way, though. You should say, hey, I'm going to take the derivative of y, which will be 1. So it'll be 1 times dy dx, which is just dy dx. Cool, this is going to be the product rule here. Let me see if I can switch it to laser pointer here. Okay, product rule. So just to remind yourself real quickly here, it's the first function times the derivative of the second function plus the second function derivative of the first. So we're just going to follow the form. So first function is x cubed and g of x. The second function is that big thing over there. So let's go for it here. So the first function comes down. We're going to take the derivative of the second function, which is negative 2/3 is the power function, comes in front over here. The stuff inside remains exactly the same because the chain rule, and then we're going to subtract 1 from this. All right, should be negative 5/3. All right, if you're like, hey, how did that happen? Real quick here, negative 2/3 minus 1 would be the same thing as negative 2/3 minus 3/3. And 3 stay the same. Negative 2 minus 3 is negative 5. Alright, I know I'm talking kind of fast. And what's going to happen is I'm going to give you the information kind of fast because I figure you can pause the video anytime you like. Alright, so we're going to try to do it that way. Let me adjust the volume a little bit more. Just a B. Okay. If that's the case, then we have the product rule says plus sign. Oh, sorry, totally forgot. So we could take the derivative of the stuff inside here. So this derivative stuff inside here is 5 times 2 is 10x. Now the plus sign comes. There it is. So second function written as it was originally. And then we take the derivative of the first function. Derivative of x cubed is 3x squared. Done. Okay, now we have to simplify. So first things first to simplify, maybe like this right here. We can simplify. It's actually this, and this need to be simplified. But let me do it in 2 steps, just so we see it. So 10x times x to the third will give us 10x to the fourth, negative 2/3, and then everything else remains the same. For the function on the other side of the plus sign, all we're going to do is we're going to bring the 3x squared in front, but everything else remains exactly the same there. Alright, then let's deal with this one right here. Let's go with negative 2/3, so 3 on the bottom. 10 times negative 2 is negative 20, so everything else remains the same. Oh, totally forgot the exponent there. Sorry, exponent over here is negative 2/3. Okay. So negative 20 over 3x to the fourth, and everything else remains exactly the same, no changes. Alright, so now, technically this would be fine in calculus. This would be the correct answer. Everything's fine. But in calculus, a lot of times, we want to put it into factored form. So we want to pull out as much as we can, particularly even fractions. We want to pull out fractions if we have any. And then whatever is left over is great because simplified form most of the time means factored form. So I see a fraction on my hands right over here, that little 3. So I'm going to pull that out. I see x to the fourth, x to the squared, x squared actually, so we're going to pull out an x squared over here. And then the fun part is going to be pulling out this right here. So let's go for it. So I'm going to pull out a 1/3 out of here because of the fraction, because I don't like stuff inside here to be fractions here. X squared gets to go out because it's the lowest exponent here. And then the fun part begins. What's the lowest exponent? Is it negative 5/3 or is it negative 2/3? What's the lowest exponent on 5x squared plus 1? Answer is negative 5/3. That is the lowest exponent. Alright, then the leftovers will be, let's see, since we pulled out a third out of here, I'm just left with negative 20 there. X squared, we still need an x squared over here. And since we pull this whole thing out, we have nothing else here. We pull that whole thing out. Okay, let's talk about exponents in general, and then we'll deal with this little guy here. So, do you guys remember from algebra, whenever you have like something like this, again, this is from my own brain, all right? So x to the fifth minus x squared. If I'm going to take out an exponent, it's going to be the lowest one. And then when you see what's the leftovers, you get yourself a 3, because x squared times x to the third gives you x to the fifth. Or if you think about it, you could think of a subtraction. I had x to the fifth. I taken out x squared, so 5 minus 2 is that 3 that's left over. And if you have a 0 left over, then you just put a 1. So 2 minus 2 is x to the 0. You have yourself a 1. So question is this right here. I've taken out a negative 5/3. I originally had a negative 2/3. How does that work? The process stays exactly the same. So if you think about it, this is what I have. Kind of like that 5 over here. This is what I have. I'm taking away, I'm subtracting out a negative 5/3. That's crazy. Okay, this becomes plus plus right here. So then it becomes 3's on the bottom, but negative 2 plus a positive 5 makes it 3 on top. So it becomes 3 over 3. That's probably the one thing in the problem that really gets students right there. Okay, the other one that gets students is this right here. I've pulled out a 1/3, but there was no fraction here in the first place. How does that work? So the question is this: what do you multiply 1/3, or 1/3 times what would give you 3 at the end? Answer is 9, right? 1/3 times 9 would give you 9/3, and 9/3 is 3. Alright, we don't need any more x squared, so we got that. And then we just learned about exponents here. This means that this is just going to be to the 1 power here. That's 3 over 3, or just 1. Alright, looking at this problem, what else do I need to do? Just simplify the stuff inside the bracket. That's what I need to do. Alright, I just kind of quickly copied and pasted from the previous slide right over here. So let's go with it. Should be almost done here. So the front part remains exactly the same. This stuff here, the only thing I got to do is distribute off the 9. So 9 goes here, 9 goes there. So let's do that real quick here. And now we're going to put things together. So that x squared and that x squared gets put back together. We have a 9 at the end. Let's do that. And there it is. Notice you have a negative in the exponent, and technically that's okay. We can have negatives in the exponents. Sometimes the book has it, sometimes the book changes it to denominator. So you kind of be mindful that it could go one way or another. So just be mindful of that. Alright. 29, here it is. Finally we get down to explicit differentiation in its glory. There it is. I see a y on the outside, but I also see a y squared actually inside a trig function, the sine function. Ooh, this is fun. Look at this. This is y squared inside this product here, right? Which is inside a sine function, which is also inside a cubed or third power function. This is going to be super fun. Alright, in mathematics, we don't really care with the equal sign, which way it's written, so I'm going to move it around just so I can see it a little bit more easier right there. So I'm going to put the y on the left, everything else on the right. And let's go with differentiation. Let's jam with it here. So, derivative of y, dy dx, like last time here, and then we're going to deal with this guy here. So this is a power of 1/2, true? Square root is a power of 1/2. So that 1/2 goes out in front. The stuff inside remains exactly the same, no change whatsoever. But now we have a power of, let's see, 1/2 minus 1. 1/2 minus 1 gives you a negative 1/2. So there's my first iteration. Now I have to do the derivative of the stuff inside. So that 1 goes to 0. Don't even care about it. Now we're looking at this guy and thinking to myself, hey, that's a power function too. So that 3 is going to go now to the outside as a product. Sine 3 minus 1 is 2, and everything else remains the same. So I just did the product only. That's going to be multiplied by the stuff inside. So now we think of, forget about the 2 here, this is just sine of xy squared. So derivative of sine is cosine. The stuff inside there remains exactly the same. Now we have to multiply this stuff here, and that's a product rule again. Product rule again says, what does it say? Just look it up if you need to. And it means the first function times the derivative of the second function. The second function is y squared would be 2y. I don't know why different. Why did I write it 2 different parentheses? I have no idea. But it's going to be dy dx. Plus, then we're going to go with the second function, derivative of the first. And derivative of the first one would just be derivative of x is 1, dx dx. So then we actually just can chop it off like that, a little cleaner to see. Alright, let's move with it here. Let's simplify this as much as we can just so it's on one single line. Let's go for it. So everything else remains exactly the same. Here, simplifying that little last part right over here. Just simplifying this right here would give us 2xy dy dx equal to y squared. Alright, this is the fun goal now. Check this goal out. We have to somehow solve for dy dx. This is nice. This one's not so nice right here. We have to somehow eventually get this guy by itself. How we do that? Let's move on to the next slide. Alright, so let's see. What should we do here? What should we do here? I'm thinking this. Let's make it into a fraction, I guess. Let's do that. Let's make it into a fraction. So that 2 is going to go down here. All this mess is going to go down here as well as a square root. And then we got the 3 on top. We got the sine squared on top, the cosine, and the rest of this over here. So this is where we kind of have to think through things here. So notice real quickly here, this is, if I start distributing, I have to distribute this. Notice there's no plus signs here, or minus signs, right? So if I distribute, it's going to go to here. We're going to have a dy dx on our hands. Here is going to go to this one, and then I'm even more trouble than I need to be. This is going to be huge. This is going to be humongous. Thinking to myself, you know what I can do? Oh, how about this? How about if I just multiply this right here, I'm going to multiply this and put it on that side of the equal sign. Technically just multiplying both sides by 2 square root of 1 plus sine cubed of x squared, x times y squared. If that's the case, so moving this all the way over here allows me to have this. I'm on the dy dx side now, and it's a multiplier to it. And then now let's see if we can distribute all this here. So distributing, hopefully you guys know where the numbers are coming from. Ask me if you don't in class, so we'll kind of get to it. I get to these slides here. Then we got to distribute the second part, which is now this multiplying into here. So you got this extra y squared now, that's all. So now it's going to be 3y squared. Sine squared, and I'm running out of room here. I'm going to write smaller just to get by. And I think I got it. Okay, remember the whole point here, what? The whole point is to get our dy dx's together and solved for. So let's do this here. Let's take this whole entire thing right here. We're going to move it all the way to this side. We're going to move this whole thing this way. I think that's going to cause what I want to happen here. So I have this side, left side exactly the same. Subtract now, because we're going to move it. We're going to move this side to this side, so we're going to subtract off 6xy sine squared and all the good stuff here. Now all that stuff is now equal to the remaining part that was on the right hand side. Okay, that's xy squared at the end, so it's still a 2. Alright, algebra skills. Here it is. What's your algebra skills telling you to do? We're trying to solve for dy dx. I have 2 terms with dy dx, and we're going to factor out a dy dx. Absolutely. So let me bring the problem back to over again. So this guy here and this guy here gets to be factored out in front. Love it. Everything else here remains exactly the same as we had it before. A lot of rewriting. Crazy. Equal to exactly what we had on the right hand side anyways. Whew, but I think we're done. Let's divide both sides by this right here. This big, humongous thing. Alright, divide both sides by that. Whew, here's what we got. We have solved it. The stuff on the other side of the equal sign becomes the top. The stuff on the side of dy dx becomes the bottom, and let me extend that a little further out. Done. Okay, let me just check. Let me just check the book, see if that's the same thing. Alright, I just checked, and yes, it is exactly the same. Man, that was a toughie. Alright. Alright, next on the list. 41. 41, here it is. Here's what we got. And I think 41 says we're going to find the second derivative, right? It's the second derivative that we're trying to find. Okay, let's go. Let's find the first one. First derivative is pretty easy. First derivative is there. So power rule, and then we got dy dx, and the derivative of 1 is 0. Okay, let's move this guy to this side here. And then we can divide by this one. So minus 3x squared goes to the other side of equal sign, divided by 3y squared. And you can kind of see what's going to happen here. The nice 3's are canceled. Negative sign is still there, and voila, that is my first derivative. So let me write it over just real quick so it's connected. So my first derivative is there, right there. Okay, now let's start the second derivative. Second derivative is going to be, so we're just going to say, look, this guy now is going to be our second derivative. It's going to be d squared y over dx squared. And this is a quotient rule, so hopefully look back at your quotient rules right here. And we're going to stick this little negative just out in front. I don't want to have that little negative to be part of the problem here. So x squared on top, y squared on the bottom. Let's go for it here. So bottom function, derivative of the top function, go minus top function, derivative of the bottom function, 2y, and we're going to declare dy dx, divided by whatever the bottom function was, now squared. Alright, let's go with it. Let's keep on simplifying. Let's see what we got here. So let me kind of, the d squared y over dx squared, that's just going to move down each time, just so we know. Alright, and on top, how about a 2x y squared? That's nice. This will be, let's see, 2x squared y, and then dy dx. Cool. And the bottom is going to be y to the fourth now. Okay, now here's our issue. So notice we have what we want, but inside our problem itself, we have a dy dx. So we have to substitute what we originally got. So this guy here is this guy here, which will then be substituted as this guy here. So rewriting everything exactly as it was, except now we're going to substitute negative x squared over y squared. Done. Okay, now time for simplifying. Alright, again, pausing it as you need to. Let's see what I would do here. I'm going to raise this to like a 1 power. Like so, sorry, this could be over 1 right over here. So let's do that here. So this is going to be 2x squared y over 1 multiplied by negative x squared over y squared, and then I can see some things happening here now. So I see that the y is going to cancel with one of these guys here, so now I have an extra y there, and then looks like as I multiply this, this is going to be, this is going to be a negative times a negative is a positive, right? 2 is still going to be here, x squared times x squared, x to the fourth, and I'm going to have a y on the bottom. So next slide, let me just kind of move this over to the next slide since I ran out of room. Alright, there's my previous answer. So how about this? I think I could probably do it here. So 2xy squared minus, or plus sign now, right? Because negative times a negative. 2 x to the fourth over y to the fourth. Okay, not solved yet. Not nice at all here. So we have a fraction on top of another fraction. So I guess what we have to do is we have to build a denominator of y right over here. So to build a denominator of y, we put a little 1 underneath there, right? So let me, right there. So we're going to put like a 1 here. If you want to just do that here, just put a little 1 here. I rewrote the whole thing, but 1 there, just we're going to multiply this guy by y over y. I'll produce that, what we need here. So now it's going to be 2x y to the third over y plus 2x to the fourth over y. Perfect. All right, then we move on to the next one here. Let's see what we got here. We're going to go with putting it all together here. So 2xy to the third plus 2x squared to the fourth, sorry, over y to the fourth. All right, keep on going. And so what we're going to do is we're going to transform this into a multiplication instead of division. So we're going to keep this exactly the same here. And then we're going to take that y to the fourth, and we are going to take the reciprocal and now multiply. So instead of y to the fourth, it's going to be multiplied by 1 over y to the fourth. And now it's a multiplication problem on our hands. Multiplying through. And we got ourselves to the fifth. Okay, now let the fun begin. We have to, again, remember how in calculus we like to keep it in factored form. I think that's the most simplest form, is factored form. So I'm going to pull out a 2. I'm also going to pull out an x out of this here. So we got ourselves pulling out a 2, pulling out an x. That's what should be the leftover out of the time that we pulled out. And then we say to ourselves, you know what, I think I've seen this y cubed plus x cubed before. In fact, let me turn around, x cubed plus y cubed. Wasn't the original problem that we started with? This is the original problem. And so, really, that becomes a 1. And then going back all the way back to the original problem. Well, the original problem was x cubed plus y cubed equals 1. If it was x cubed plus y cubed equals 2, we put a 2 in here, right? So whatever it actually said. All right, so I think we've done, that's a multiplication by 1 now, and look at this. The second derivative looks very easy, very nice, very plain. It's just negative 2x over y. How good is that? Let me check the back of the book. Let's see if we are correct. And we are correct. Awesome. Oh, y to the fourth. Okay. Sorry, forgot to mention that one. Sorry, I forgot the little 5 there. So y to the fifth. So x. Sorry, I did forget the y to the fifth. There you go. Now that I'm seeing negative 2x over y to the fifth. We dropped that one. Okay, problem number 45. Here it is. Let me look back to the back of the book what it means. I think this one is the second derivative, right? It wants to know the second derivative of this one. Oof. Okay, I just want to say this will be crazy, okay? Just so you know. All right, let's go with it here. So hopefully you recognize that's a product rule right there. Product rule says, there it is again, first function, derivative of second function, plus second function, derivative of the first. So let's go for this. So first function is there. And now we go with derivative of the second function. Derivative of cosine is negative sine of y. Then we take derivative of y, which is 1, and we declare that we just took a derivative of y over with respect to x, plus the second function now gets put down, and then derivative of the first function, which is just x, and again, we don't need to write anything down here, but on the second one it's going to be derivative of y, which is 1, but then we have dy dx. Okay, so whole goal here is, can you solve for dy dx at first? So I'm thinking, let's see, negative goes out over here, x is here, sine of y, dy dx, that's cool, that's nice. This one's just going to be cosine y, that's fine too. This one's just going to be dy dx. So I guess the only thing I'm going to do is I'm going to take this guy over here and just swing it over to this side. That'll be the easiest way to solve for dy dx. So cosine y stays on the left, dy dx, now it's a plus x sine y dy dx. And like we did on the last problem here, we factor things out. So dy dx, over 1 plus x, well, not over, but distributed out, factored out, and we're left with 1 plus x sine y. Okay, let's divide. Let's divide that out so that dy is all by itself. This I think you guys can do. And we're left with cosine y on top and a 1 plus x sine y on the bottom. Perfecto. Alright, what else we got? What else we got? Now I've got to take the second derivative. Oh, great. Let's do that. Okay, it is kind of fun, I got to tell you. Alright, first derivative right there. Second derivative. And a quotient rule over here, right? Quotient rule. So d squared y over dx squared is going to be quotient rule, here it is, derivative of that is second derivative of the first plus first derivative of the second one divided by the second squared. Let's go for it here. So the bottom function, exactly the same, no change, no change. Derivative of the top function, derivative of cosine is negative sine of y, then derivative of y, we declare dy dx. Alright. Ooh, you know what? Sorry, it's a minus sign, right? I'm thinking about it here. So sorry, minus sign, not a plus sign for quotient rule. Sorry, my fault. So minus sign for quotient rule. Alright, now we are moving on to the second derivative. Okay, so remember this is going to be quotient rule here. So let's go with it here. So d squared y over dx squared. And this is quotient rule, so just remind ourselves about the quotient rule is second function, derivative or bottom function, derivative of the top, minus top function, derivative of the bottom function over bottom function squared. Let's go with it here. So g, no change. Bottom function, no change. Top function, derivative of cosine is negative sine. Y, derivative of y, dy dx. Minus sign for our quotient. Then let's go with top function now. No change. Bottom function. Ooh, bottom function is a product rule. So 1 goes to 0, but I got a product between x and sine y. So first function, derivative of the second function, derivative of the inside function, dy dx. Plus, this is product rule, right? Plus derivative of the first function times the second function. So that's fine. There's the derivative of that one. And then in the bottom, now it's going to be whatever we had there previously. Ooh, I'm missing the x over here. There should be an x right over here. And I should write it in. There's x right there. Alright, boom. And this is so easy to sort of see or forget little things here. Just one little mistake sort of gets you. Okay, so first things first is this. I have this 1 plus, there's two terms here, right? Two terms times a one term. So we're going to take this 1 times this, gives you negative sine y dy dx. Then it's going to be this times this. So now it's going to be x sine squared y dy dx. So I kind of in a sense distributed this little piece here and here. On the other side, I'm going to distribute the cosine y to this guy, then cosine y to that guy. Whew, here it is. So x, this is going to be cosine squared y dy dx, and more room. And then minus sign, because of the minus here. That's going to be cosine y times sine y. So we usually write the sine first. And then the bottom remains exactly the same. And I'm still missing my little x again. So x right inside here. You should see an x right there. Alright, let's see if we can simplify this some more. And what I see, let's see, what do I see? What do I see? Oh yeah, dy dx. We have to substitute back in. So I see a dy dx here, dy dx, and a dy dx. So I'm substituting all the dy dx's back, what we got. Oh, from right here, from on top, right here. So let's go with it here. So negative sine y. Now, there it is. Cosine y over 1 plus, oh good, I remembered my x this time. So x sine y minus x times sine y squared over my dy dx originally. Oh, this is so much fun. Minus x cosine squared y over, or times by, all that again. Ha ha ha. Okay, and here's my little problem. So notice I have it on this one, and this one. Here's the tricks of algebra. You guys ready? Pay attention here. So if I have the same denominator, notice I have the same denominator here, here, and here. So what I want to do is to create another denominator here, the same one. Tricks of the trade, here it is. I'm going to multiply by same exact thing on top and bottom. Technically, I'm multiplying by 1 right there. All right, I'll show you in just a bit why that's so significant. Okay, so notice that all these guys have now, I've made it, I've kind of sneaked in an extra denominator, so I have made all these guys to have the same exact denominator on top. Okay, real quick I want to show you why we do that and why it's helpful, because if you just stuck with 3 of them, you're going for another 10 minutes on this problem. So let me show you just a quick example from algebra. So from algebra, let's say you had this. Let's say you had 2/3 plus 5/3 plus 10/3 over 3. Again, don't need to write this down, just kind of quick little thing. So notice you have the same exact denominator here as in down here. Right? So notice what happens here. So if we were to add up the fractions on top, 2 plus 5 plus 10 is 17. And notice what happens here. I would just then take the 17/3 and I would do the reciprocal of 3, which is 1/3, and multiply these guys together. And notice what I have is I have now a 9. So now the question is this: can I do that directly from there to there? So what's the little rule that I can follow? And the little rule that I can follow is this: add your numerators on top together, and then all you do is you're just going to multiply by that bottom denominator there, and voila, I get the same thing. We good? Okay, that's a little trick of the trade for this problem. Let's go with our problem now. Bring this whole behemoth again over here. There it is. What do we know? We're going to rewrite our numerators that are on top exactly as they are, and we're going to multiply by 1 of the 1 plus x sine y times this one, which will just change this to a 3. That's it. That's all it's going to do. So let's go with it here. Craziness, here it is. Again, algebra on steroids. Here we go. So because that denominator is going to sink down, so all these denominators in a sense get converted and sink down into our denominator over here. Voila, I got myself a 3. And now let's just kind of put the tops together. This is negative sine y cosine y. This is negative or minus x sine squared y. Yes, minus x. Oh yeah, sorry, the cosine y there. Minus x. So this is going to be cosine cubed y. As you look at these guys being multiplied together. And the fun part. Now let's just distribute this. So sine y cosine y gets distributed to the 1. Don't forget there's a minus there. So this would be this times 1. Then it'll be negative sine y cosine y times the x sine y. So this would be x sine y squared, or sine squared y cosine y. Ooh-wee. All right, I think we're getting close here. Let's see. I think the only thing I see is let's see. Yeah, these guys right here, these two right here. These guys are exact. Nope, not those. Let's. Oh yeah, this one here. That's that one and that one are exactly the same. So let's put these guys together. Sine y cosine y with a minus in front. Minus sine y cosine y. Love it. So let's go for it. Let's put this guy in front. Okay. Let's write our denominator out so we don't forget this guy. So how about minus 2 sine y cosine y? And then I think that is it. Let's see if there's anything else. Oh no, hold on. There's another one here. There's another pair. This guy here with the one all the way at the end over here. There's your sine squared y cosine y with an x in front. Perfecto. So I'm going to go with 2 of those. And then we're left with just this little one right over here. That's there. Okay. Okay, we're getting closer. Alright, one more thing we're going to do. We've seen this in previous problems as well. If you notice, whenever you see like a little negative in every single term you have, right? That's about time to kind of put the negative on the outside. That's about time. So we're going to put a little negative on the outside of our fraction itself right there. Okay, and then we're going to rewrite everything in terms of what we have left over. So this now becomes a positive 2 sine y cosine y, positive, and a positive. I like that much better. Okay, over the bottom denominator as is. Okay, now I should tell you something here, real quick here. So a few things you want to think about and kind of put together here. So first things first is you want to think about your original function. So we already got rid of our dy dx's, right? We already got rid of our first derivative stuff. So I want to just say this. 3 things to keep in mind as we simplify this problem. You want to keep in mind the original problem itself. So x cosine y equals y. Keep that in mind as we do this. The other one to keep in mind, you've seen this before, it does come up a lot in calculus, is the double angle formula for sine. Look back to your trig functions if you need to, but there's your double angle formula for sine. So if you see a 2 sine y cosine y, or a 2 sine theta cosine theta, the simple form of that is sine of 2y, or 2 theta. Right? And the other one to keep in mind is, obviously, it is the Pythagorean Theorem. So whenever you see sine squared plus cosine squared, you know you're going to get a 1 out of that, because that is the whole concept of the Pythagorean Theorem in trigonometric form. Alright, let's go with it. So what do you see? What do you see? Obviously right over here, right in front, we see that guy is going to be substituted as a sine 2y right there, right away. Boom, done. Okay, what else do we see? I think I can pull out a original function of y out of this. So I'm thinking there. And then anything else that we can kind of see here. Oh, you know what? Even better yet. Okay, we could do that, yeah. And if you did it that way, that's fine. I think I can also pull out there's my x, right? There's my x here, and then there's a cosine y over here. So I can even take out, in fact, let's even take out an x cosine y out of this whole thing. Let's see what happens. And so let's, again, here's my substitutions, and let's go with it here. So this is a minus on the outside. So substitute this, now becomes what we need it to be, but let's rewrite our denominator just so we have it, so we don't have to mess with it later. So let's go with it here. On top, I got myself a sine, that little 2, as I wrote it, that's not sine squared, it should be just a sine 2y over here, sine 2y. Alright, sine 2y. Don't write it as a 2y squared. I was kind of going crazy with the pen here. Okay, this one is I'm going to take out x cosine y out of these two terms here, because I want to eventually get that to just be a y value. So leftovers would be a 2, a sine squared y, plus cosine squared y. Ooh, I'm getting closer to something here. Okay, let's do our substitutions. Let's see how we do here. So I'm going to, leave the denominator exactly the same as is again. Sine 2y over here, plus now this is just turned into a y. There's my original function. And now how are we going to play the game here? How we're going to play the game inside our parenthesis? I know. I think I'm going to do this. I'm going to separate the sine squared y's away from each other. Remember, because I have two of them, right? There it is. I'm going to split those guys off. Split this, two different pieces. And then this piece right here is going to be, that's just going to be a 1. So let me show it to you again here real quick here. Let me write it there. So now I got myself sine 2y plus y, and now I got sine squared y plus 1. There it is over my denominator. Alright, that was a long one. That was a long one. Let me check the book. Let me see if we are correct. And that is exactly what we have for 45 in the back of the book. Awesome. Sweetness. All right, next one we have on our list. 49. 49A. Actually, this is the last one now. This is cool. Okay, last one. Here it is. All right. It says, it actually says, when do you not have a vertical asymptote? Let me find the book real quick here. I'm going to it here, 3.6. Okay, where does the equation not define y as an implicit function of x? When can you not have an x function for a? All right, so let's do this. Let's draw this out. I'm drawing it out. And I don't know if did you guys see this? Did you guys see these in where? In trigonometry, when you guys were graphing cardioid functions, right? And this is called a lemniscate. Lemniscate. All right, let's go with it here. So when does you can't define an x function? You can't define an x function when things go vertical, right? Because there's no way that you can find a vertical type. So right here and right there, there's our trouble. There's where you can't define it here. So all we got to figure out is, notice it is right along our x-axis, right? So y equals 0 right here. Y equals 0. And so in that case, it can't be defined. So let's jam with it here. So when you see this, we can define an x function. That's all. So let's find out when does this happen. So let's put in zeros for all the y values we have. Let's simplify all this stuff as fast as we can. All right, and let's factor this stuff as fast as possible. So I see x to the fourth, I see x to the second, so I'm going to set it equal to 0. Let's move the 100x squared over. And we're going to factor the highest thing that we can possibly do. So I can take out a 4, because 4 goes in 8 and 100. I can take out an x squared. So 4x squared gets to go out. I'm left over with 2x squared minus 25. And then 4x squared set equal to 0 would give me x equals 0. And then we have 2x squared minus 25 equals 0. Ooh, this one, remember these guys here from Algebra 2. What we have to do is we move the 25 over. We divide by 2. And this is called the square root property of solving an equation. All we do is we're going to take the square root, both sides plus or minus. And we get ourselves, hey, look at this, this is funny. So 25 is a perfect square. That becomes a 5. And the 2 is not a perfect square. It stays as radical 2. In fact, we're just going to keep it just like that. We're not going to rationalize our denominator. Why? Because I looked at the answers in the back of the book, and they don't rationalize our denominator. That's why. So you could do it, you cannot do it, kind of depends, totally depends. So let's go with it here. So let's see, when y is equal to 0, the x's that are formed are 0, 0. That's when the value is not defined for x. When plus or minus 5 radical divided by radical 2, 0. So there's 3 points. There's 3 points where these guys are not defined. Okay, next one. Use implicit differentiation to find the equation of the tangent curve at the point 3, 1. 3 comma 1. So first of all, before we even get there, let's figure out what that means. So this is 59b. Here's our limb skate. And 3 would be about right there, going up to 1. So we're looking for that right here. We're looking for the equation of the tangent line. So that's what we want. We want the equation of a tangent line. Alright, let's go with it here. I wonder if this is going to be easy to take a derivative of or not. So, I don't know. I have my doubts. Okay. Alright, here's our original function. Let's go with taking the derivative of that. And then we're going to do it implicitly. Let's jam. So, let's see, 16. So 8 is just a constant. So I see a power rule inside here with that little 2. Then I see derivatives inside. So chain rule. So 2 times 8 is 16. Then the 2 goes down to a 1. Then we take derivatives of the stuff inside. So derivative of 2x, or x squared is 2x. Derivative of y squared is 2y with a dy dx after it. Other side. Alright, 100 is just on the outside there. So 100 is a constant, right? And then we have ourselves, inside the function itself, it's 2x minus 2y dy dx. There it is. Alright, so the whole goal now is, can you solve for dy dx? That's what we got to do. Some crazy stuff ahead of us. Let's go with it here. So first things first, just to clean things up, I think I'm going to multiply the 16 into here. And then multiply the 100 into each one of these guys here. So that'll be easy to do. There it is, 16 multiplied in. And so now we'll have two binomials multiplying each other. There's two binomials. Well, that's going to be the FOIL method. Equal sign, multiply 100 into each one of these guys. That's cool, and I got myself a FOIL method right here. This would be fun. This times this times that. Inside, and last ones. Let's jam. So do it yourself. Do it slowly. I'm gonna just kind of put the result that I got. All right, that's what I got for the result as I FOIL all that out. On the other side, everything else left exactly the same. All right, pause the video if you need to do that. All right, next things first is let's do this here. The quick way with math. We want to be able to solve for dy. Let's move every single term that has a dy, leave it on the left or move it to the left. So let's move this guy over to the left. Everything that does not have a dy dx to it, we're going to move it off to the right, and that would be the easiest way to do so. So pause the tape, do it yourself. Not tape, pause the video, do it yourself. I'm in my VHS tape days here. So that stays because that was already on the left. That stays because that was already on the left. Let's move the 200 over. Voila. Now every single term here has a dy dx. And then on the other side, the 200x stays, but then everything else that doesn't moves over. So this guy moves over. This guy moves over. Okay, and we know we're going to factor out a dy dx, right? We're going to factor one out, and then we're going to divide by each one of these here. So let's kind of do these two steps at once, so we have to rewrite everything all over again. So the stuff on the left is going to be at the top. The stuff on the right is going to go down to the bottom. There it is. We have found our derivative implicitly. Now, for our tangent line equation, the only thing we want out of this is our slope. That's all. That's all we care about. We care about what's the slope of this line, because that will give us what we need to process this. All right. Okay, before we plug in the 3, 1, which you can right now. You can do that right now. But usually in mathematics, what we like to do is we like to simplify stuff. If we we could simplify stuff, that'd be fine. But you could have plugged in a 3.1. I just wanted to show you just kind of like the simplification here. Now you probably find it the fact that, no, I should have just plugged in 3 and 1 into it already. So in this case, on top, what we think about is we're thinking, okay, what's the biggest number that goes into 32 and 200? And the answer is 8. And is there x in all three terms? Yes, there is. Let's take that out. If you factor that out, you'll be left with this right here on top, verified if you want to. On the bottom, we're going to have the same exact number pull out, right? 8. Then y's are in each one of those, so y gets to be pulled out, and voila. Oh, bummer. I would have been able to cancel this stuff if it were not for plus signs here. So that's what I'm left over here. So notice the 8's can be canceled, right? There it is. 8's are gone. Those can be gone and over with. And just to show you just a fun little thing here. If we do that, and then we notice those little 4's there, if we take out a 4, we're left with x squared plus y squared. And on the other side, we take out a 4 out of here, we're left with x squared plus y squared. So that's a little interesting thing there. So how does that really help us any? When we plug in the 3 and the 1, the 3 comes in here, and that's just going to be 3 squared, which is 9. The 1 plugs in, it's going to be 1 squared, which is 1. So this whole thing is really a 10. Right? So let me show you the plug-in to it here. Let's see. So as we plug it in, this becomes x becomes 3. 25 minus 4 times, again, 3 squared is 9. Plus 1 squared is 1. So those became the same. 3 times 25 minus 40. 1 times 25 plus 40. That's really the difference there. 3 times a negative 15. On the bottom, it's really 65 itself. And we can cancel alpha 5 out of each one of those. And there it is. Our slope of the tangent line is negative 9/13. If you got that, just plug it in 3 and 1 into all this right here. That's cool too. So just kind of show you the factored form first before I start plugging in. And I don't know, vote here. Just take a quick vote. Which way would you prefer? Simplifying it out first, then plugging it in, or just plugging in the numbers would be done? Alright, we're almost done here. So, do you guys remember this guy from algebra? I've mentioned it to you guys several times already. So, if we change that, that's going to be our negative 13 ninths, right? That's our slope because of the derivative and plugging in the value. And then the values themselves are 1 for the y value and 3 for the x value. So let's plug it in. 1 minus y equals negative 9/13 x minus 3. And just as soon as you get that to the end, you're done. If you look at the back of the book, it actually puts it into something called standard form. It wants the x's and y's on one side and the constant on the other. So we're going to have to do that. So let's go with it here. So first things first, let's distribute the negative 9/13 here and there. If you do that, you should get this as the answer. Then to get rid of the fractions, what you're going to do is you're going to multiply everything by 13. So both sides by 13. Then this is going to drop the 13 on each one of those. And let's see what we got. We're going to take this little negative 9x, we're going to move it over here. We're going to take the 13, move it over there. So it should be like this, 13y plus 9x because we moved it. On the other side, it'll be 27 plus 13, which is 40. And for standard form, we write the x first, followed by the y, followed by the equal sign, followed by the constant. And looking at that, it looks like, I've got to find it here. It's the same. Yes, 9x plus 13y equals 40 is what I have there. So trace the curve and sketch the tangent line. So actually we already did that, so why do that again? Okay, I'll show it to you. 59C, there it is. If you want to do it You can extend this out further if you like, but oh, let me change it to pin. Okay, there's my tangent line. That's kind of what we're doing, but I graphed it before we even started for you guys to visually see it.